We have developed a new shading model for finished wood surfaces that accounts for reflection from fibers that are not parallel to the surface. Our first example is a sample of curly maple. We begin with reflection measurements. Here, you see the sample viewed from directly overhead as the light moves in vertical sweeps. The three-dimensional wave in the grain causes bands that run across the grain direction. We fit our shading model to all the light positions for each pixel, producing parameter maps that we can use to re-render the samples. Here you see the rendered model compared with the measurements using the same set of light positions. The distinctive appearance of the wood is reproduced well. By projecting the fiber direction map onto the surface, we can compare to Ward's anisotropic reflection model. Ward's model cannot properly capture the distinctive stripes in this wood because they are caused by out-of-plane variation in the fiber direction. The second example is straight-grained walnut. This wood has subtler but still noticeable ripples in the grain. The fitted model captures both the general appearance and the small ripples. Because the grain is nearly parallel to the surface, Ward's surface-based model is more successful, but it still misses the subtle ripples. The third example is African podoke. This wood exhibits interlocked grain, which means the tilt of the fibers varies across the fiber direction. This results in moving bands along the grain direction. Again, the fitted model captures both large and small features of the appearance. In this sample, the variation in fiber direction has components in the plane of the surface as well as perpendicular to the surface. Ward's model produces shifting bands based on the in-plane component, but they do not match the bands in the real wood, and they are missing many subtle features. Finally, we show each of the three samples rotating on a turntable with a point light source. On the left is video of the real sample, and on the right is a rendering using the fitted parameters. The parameter maps being used for these renderings were fit to the overhead views only, so these sequences demonstrate extrapolation to novel configurations. This second sample of walnut is straight-grained but contains a knot, which locally distorts the tree's growth. This results in out-of-plane fiber directions that cause contrast reversal as the wood rotates, which is matched well by our model. Our new shading model is easy to incorporate into any rendering system. It provides a simple, effective way to reproduce the beautiful appearance of finished surfaces from common to exotic woods.